Welcome back, friends. In the last video, we saw our code, how we can use NumPy vectorization and how it is fast compared to the standard Python for loops. So, in this video, the silent work, memory management and advanced NumPy. So, we will see how we can create and our system can crash if we will not fix this bug. So, the thread to your RAM. So, you can see the first point here, silent bug. Python allows you to accidentally overwrite massive dataset without even throwing any error. So think, for example, if we create an array and we slice it and create a smaller array. So like I created here array. Okay. And this we can take B. And we change and we are creating slice for this one. So if I create slice this one, A, and this will also point for this one, and we update any value like a0 equals to 99, and if we have array 1 2 3, then both value this will be changed to the 99. So for this one we will see in the practice how it will work exactly. Next we have hardware constraint. When training locally on a machine with inefficient memory management will press our pipeline. So you can think of that like if you have millions of data and if you are training locally and if you are not using and managing properly, not doing proper memory management, how it will crash. So this will also be so in the Jupyter Notebook using example. So learn today, control your memory footprint and hardware levels. So what is view? So this is like the weight V and weight A. So like we created array. This is you can say array weight A. Okay, this one. So we have 1, 2, 3, 4 value here, and we create weights A02. So here we are creating the slice. So this is also pointing to the same array. So you can see this. So it's pointing 0 and 1, two element for this one. So what is happening here? The misconception. Beginners think this command grabs the data and move to it to the safe new location in the RAM. But this is wrong. It is simply we have original array and we are slicing. So it simply create the view for this one and so the same thing. So the reality NumPy creates view and it generates new variable name, but points it directly at the exact same physical memory as the original array. So that's what I explained here. If we have array A and we're creating the slice using like this, and we are modifying here anything, like if I modify weight V0, so it will override this value. Like if I put any when 2 or 5, so the base value also will change. So the golden rule, two variables, one block of memory. If you alter the view, you permanently mutate the original data. So forcing copy. So how we can avoid this? So we have solution. We use the .copy command. So what it does, like forcing the CPU to allocate new physical separate block of RAM of the slice data. So how we will do that? When it is always use .copy when splitting data into the training and testing set. So slicing the weight we are using weights A, like we are slicing and we are using copy, so it will create new copy here, and if we modify here it will not modify our original data. So our original data 1 2 3 4, and here you can see the output is 55.0 here, and the original will be same only. This in place operation saving gigabytes. So like I was explaining, if we don't have enough memory and we are not doing memory management, so it can crash our systems. So the standard how we can do x equals to x into 2, so it creates massive temporary array in the memory, doubling your RAM uses for a split seconds. For a small number of data, it will not create any problem. Think for machine learning models, we need to use millions of data. So we create same copy for data, so it will crash the system. So I have current memory 8 GB, and we are creating original matrix 8 GB memory block, and we are creating temporary block also. So you can think it will be the current memory, this will be 16 GB. So here we have chances that it can crash the system here. So in place math, what it will do, it will overwrite the existing array. So we use the in place way x multiply equals to 2, so that tell NumPy to override the original memory block directly. So it will be perform any operations, it will modify in this block only. So the result 0 temporary memory override. So like it's not required any extra memory, but we use x equals to x multiplied by 2, it will require extra memory. So advanced indexing, Boolean masking. So the problem, we need to filter millions of data points, but using a standard if loop is incredibly slow. So what we have solution here, we have Boolean masking. Yes, Boolean masking. So we create a condition that generates an array of true and false value and pass that mask directly to the matrix. I created here example like instantly dropping dark background pixel into computer vision Python. So I have original array, okay, 10, 20, 255, 128, 5, 250. So the condition we have, we need to check pixel that is greater than 100. So what we are doing, we are masking this once. We are creating and we are checking each condition for that, and we are assigning false and true based on the condition. So here we are doing Boolean mask. After that, applying the mask like this pixel and mask. So what we are doing, we are here this we created the Boolean mask. Okay, filter to this one same. Now we are filtering results. What was the condition? Pixels greater 100. It will keep the true value and other value will be ignored. So we'll see the code now. So what we saw in the PPT like silent bug, view and copies, memory management, memory optimization, in place operation, avoiding the RAM spec, and advanced indexing like Boolean masking. So first that will be same. We imported NumPy, so we have to run this one. Now, so when you slice NumPy data, it does not create new array, it creates view. So that all we already know. Thank you for the think of the view like secondary camera looking at the exact physical block of frame. If you alter the view, you permanently mutate the original data. Python will not throw an error. So it is saying like if you have one camera that is focusing on like recording in one room, and you place the second camera, but if you are that place on particular part of that room, but if you modify or to make changes in that particular position, so both the camera view will be changed. So we create a here NP array, and here we are creating the slice. So now we are updating the slice. So now we will check what will be the output. Here you can see the new weight is 99 and 2, and original weight also got 1. We are using here the NP share memory function, weights A and weights B. So if it is share memory, it will return true. So how we can fix that, like using the dot copy function. So we are using weights A 0 dot copy and weights. So here we created weight C and we are assigning 55 here. So we're printing original weights and weight C, and we are calling same function np dot share memory. So weights A and weight C here we are passing. If I run this one, so if you can see the 99 to 3 and 4 it is there, but for weight C is 55. It's not changed to the weight array. So same we are having, do they share memory? False, because they are not sharing any memory. Now we have created copy. What is the in place operation of preventing the RAM spy? The massive data, we are creating np.1 5 by 5, and we are doing massive data into multiply to like in place operation here, so it will override the existing one. So Boolean masking the. So here we are having np.array. Now we need to first, and we have mask. What is the pixel should be greater than 100. Here we are printing mask. Here we are created mask. Now we are applying the mask like pixel mask here. So it will return the bright pixel. So if I print here, so you can see it's true and false. Here we are creating the mask pixels greater than 100. So these three values having 100, so it will be true. After that bright pixel, so it will return 25 and 20 200. And here and down there we are updating the pixel less than 100 0. So we are assigning the 0 value for the dark pixel. So this is the what we learned in today's video. Please like and subscribe in the next video. So in the next video we'll see the pandas and how we will feed the data, like we can clean the data before passing to the NumPy. So please subscribe and share and support me. Thank you.